Go. We're going to do engine repair 2 test 7, and Quincy just walked in. That's good. And it shouldn't take us too long to go through this. These are pretty good little questions though. And we're basically talking about some ignition stuff this time around. Who knows what the difference between the primary and the secondary is on the ignition system? Primary is the low voltage side of the system, which is the little wires. That's what triggers the coil to fire. On a relay, the primary is the part of it that goes to the coil that triggers the coil. The secondary is where the work is done. The secondary does the heavy lifting, and the primary is the boss. Got it? You got that? So the primary low voltage ignition system must be working correctly before any spark occurs from an ignition coil. Which of these is not in the primary ignition circuit? A, pickup coil. B, spark plug wiring. C, ignition switch. Or D, ignition module igniter.
I'm going to go with B.
Now wait a minute, secondary does the heavy lifting. So which part of it is your high voltage, your popping going on? Don't play dumb.
I'm going to guess that A is what is not in the primary.
It actually is. It actually is where the signal starts. The spark plug wiring is your secondary, okay? Make sure you get that clear in your mind. The ignition module has direct control over the firing of the coils of an ignition system. Which component triggers or controls the module? Some of this is just semantics, you know what I mean? If you hear primary and secondary, sometimes you hadn't heard it used in that kind of language. Okay, that is all of the above. Pickup coil, crankshaft sensor, computer. And then number 3 would be distributor ignition systems can be triggered by A, a Hall effect sensor, B, a magnetic sensor, C, a spark sensor, or D, either A or B.
D.
That's going to be A or B. What's a spark sensor? I used to stuff little answers in some of my multiple choice questions when I was writing questions, and I would put something in there that didn't even have a correlation with reality. I'd put something like a heated hydrocarbon vent. You can make something sound really official, and if people pick that answer, you know they didn't study. Ignition coil primary resistance is usually what? What would be your ignition coil primary resistance? What would you think? That would be the 2 small wires on your coil. If you were to measure them with an ohmmeter, what do you think you would see?
B.
From less than 1 to 3 ohms. It's almost a dead short, believe it or not. Now these coil pack coils will usually have about 6 to 8 ohms on their primary and about 12,000 ohms on their secondary. And to measure the secondary, you'd have to go to your 2 companion towers and go there. Coil polarity is determined by what?
D?
The direction of the rotation of the coil windings. Here's another little thing. The coil like you see on that board over there, that blue coil that's up there on the top left corner, if you reverse the polarity on one of those, it's going to affect the way the vehicle runs. It's not going to run worth a flip. You can reverse the polarity. Now look at that other coil. See the one in the middle, the little E-core coil? That's right by that little rusty distributor vacuum advance. It doesn't matter on those if you reverse the polarity or not. It will run just fine either way. And so that's just something you can remember. You know, take that to the bank. All right. Let me see here. A compression sensing ignition system uses what kind of ignition? Now there's a term there. If you hadn't heard it before, you're going to be confused by it, and that's waste spark. Waste spark. What's waste spark mean?
I guess to get rid of unneeded stuff.
Isn't that where there's 2 sparks happening at the same time?
Yeah, they are in companion cylinders. One of them has no reason to be there at all. But it can tell by its paying attention to which one of those is firing. It can tell by, you know, by the different resistance which one is actually on compression by measuring the amount of spark that's going. So it knows whenever each cylinder is on compression. Because what does the spark have to do when it's traveling? What does it have to do? It has to punch a hole in something, doesn't it? Basically, it has to punch a hole in air. How many of you ever heard a sonic boom on a jet?
Yeah.
Boom! You scare the daylights out of you because you don't usually know it's coming. It goes boom. That's the same thing as lightning, basically, because what lightning does is it punches a hole in the atmosphere, and whenever it goes away, all the air that it punched out of the way has got to go back in there and come together, and that makes that boom. It's like a sonic boom on a jet. Same deal. The air is an insulator. Okay, what is it that helps the spark fire in the cylinder that's getting ready to light off?
You see, air and heat.
Well, fuel molecules. Well, you're thinking diesel, but fuel molecules help it light off. I mean, and the reason that you have a scope pattern, whenever your scope pattern's got your firing line, and I've drawn this before, and I'm gonna draw it again. On your, if you're measuring that with a scope, your scope pattern's gonna have a firing line, and it's got a little table, and then it goes up, and then it's got a little squiggle like that. The reason it goes up like that, it has that up kick, is because the farther it burns, the longer it burns, the more fuel is burned up, and finally when it runs out of fuel, that spark burns out because it's harder for it to, it can't stay there anymore. And this is leftover energy right here. If you're ever looking at a scope pattern, and this right here doesn't have squiggles, like if it's doing like, if it looks like something like that, you got a weak ignition coil typically, or something that's robbing some of that primary current. Basically, this right here is how much it takes to jump the spark. This is how much it takes to keep it there, and this is how long it stays. In other words, this is how much it takes to keep it there, and this is how long it stays. This right here is your millisecond duration. This is your spark, your spark line. This is your firing line. Firing line, spark line, milliseconds of duration. It's going to be, whatever go this way, it's not going to go that way, okay? If you're reading the scope, what goes that way won't go that way. So the taller this gets, the shorter that's going to get. Make sense? All right. Now let's see here. The pulse generator does what? A, signals the computer that fires the spark plug directly. B, fires the spark plug directly. C, signals the electronic control unit, quote unquote module, used as a tachometer reference signal by the computer and has no other function. That's actually signals the electronic control unit. Two technicians are discussing the coil on-plug ignition systems. Technician A says they can be called coil near plug or coil by plug ignition systems. Technician B says some can use ion sensing. Which technician is correct? Both of them is correct. Quincy, the one that you're working on, is it coil on plug or coil near plug?
Coil on plug.
Excuse me? Hello? Coil on plug or coil near plug?
Coil near plug.
Coil near plug because you're a little short spark plug wire, right? Not coil on plug, coil near plug, and you got 8 coils. All right. A waste spark type ignition system fires what? All of the above? They scramble the answers, and A is all of the above, which, could that be possibly correct? Okay, so who did that? Who scrambled those answers and put A is all of the above? I've never seen one do that before. That's outstanding performance. That's number 9 would be all of the above.
Is it?
Yeah, it's basically one spark plug with reverse polarity, one spark plug with forward polarity, 2 spark plugs at the same time. All of that's right. And what does that mean? That basically means that you got the 2 companion plugs. If you've got good plugs, they'll be a square. They won't be, And then let's just draw this companion over here, like that. One of them fires this way, and the other one fires that way. Got it? On coil, that's the ones with the coil packs that are firing companion cylinders. Now, if you've got coil on plug, the difference with coil on plug is you can have a different ignition timing for each cylinder. You can have whatever you decide you want to do. I mean, if you got a knock sensor that's telling you got a ping in one cylinder, it can retard the timing in just that one cylinder. Well, see, these other ones can't do that. Not as far as I've ever known. But anyway, the technician A says the defective crankshaft position sensor can cause a no spark condition. Technician B says a faulty ignition control module can cause a no spark condition. Which technician is correct? Both of them. Technician A says inductive ignition systems supply battery voltage to the positive side of the ignition coil and pulse the negative side of the coil, often on the ground, to create a high voltage spark. Technician B says if an ignition system uses a distributor, it's called a distributor ignition system. Who's right about that? That's C. Now, the ignition coil is basically a transformer. And what you do there, you got a few windings on your primary side, you got a lot of windings on your secondary side. And so you've got, what you're going to do is you're going to saturate the secondary windings with the magnetism that's created in the primary windings. And when you break that, like when you open your points on a points distributor, and that magnetic field collapses, it creates a gigantic spark. But you're going to get lots and lots of, it's going to be perfectly, let's say this. This is the way, when I first started learning about this, your primary side of your coil is them little wires, and then your big one being the one that comes out of the middle. Well, this primary winding is basically going to have, let's say, not very many wraps. Right, now there's an iron core in the middle, and it's the secondary winding is actually going to have lots and lots and lots and lots and lots of wraps, like millions. Like look, the wire, if you cut open a coil, is a little teeny tiny thread. It's so tiny that you can stretch it across the door and somebody walk through it and not even know it was there. It's a little tiny thing. But it goes round, round, round. So you multiply the number of windings. If you got 1,000 windings and you got 1,000,000 windings, you've multiplied it by a factor of 1,000. Right? So if you could put 12 volts in there, you're going to come out with, what, 12,000, right? The secondary winding is the one with all the little tiny windings. And that's why it's got so much resistance. How much did I say it had? If you were to take your ohm meter and put it into 2 companion towers on that coil over there on the board, what would you get? About how many ohms? I said it a while ago.
Less than 1 to 3.
Now that's the primary. You got that one remembered. 12,000 ohms usually if you go on the end of the other ones. And that's typically true on just about every one of those I've ever measured. Let's see. Because of what? An ignition coil cannot be fully charged, which would mean reach magnetic saturation, until after a delay of about 10 milliseconds. Inductive reactance. Anybody ever heard of that? Inductive reactance. I have also called it, I think, called inductive reluctance. But as soon as, what happens is, if you run current through a wire and it's saturated with magnetism, that magnetism fights the current that's flowing through the wire. Got it? And so as it gets magnetized, you know, it doesn't like current. And so you got to keep going until you get it saturated. Technician A says a pickup coil can be tested with an ohm meter. Technician B says ignition coils can be tested with an ohm meter. Would you say both those guys are right?
Yes.
Or is one of them a yo-yo? Both of them are right. I've noticed something about technician A and B. I've known these guys for years, and neither one of them is right every time. Sometimes both of them are wrong, sometimes both of them are right. All right, let me see. Technician A says a thorough visual inspection should be performed on all ignition components when diagnosing an engine performance problem. You think he's right? Come on, you guys, don't play dumb.
Yeah.
All right, then. Technician B says platinum spark plugs can be regapped after use in an engine. Who's correct about that? A only. What kind of spark plug did you put in that GMC?
Those.
Don't say those, that bad word. Tell me what kind of spark plugs they were. No, I don't know the brand. What type of spark plugs? What were they? They weren't platinum. They weren't copper. Now you guys put some in that other one over there, and those were platinum. The ones he put in there were
Iridium.
iridium. Hey, he remembered. Or did somebody put a bug in your ear? I see that bug in your ear. Okay.
14.
All right. So those were $8 a piece, and I told him not to bust any of them. I hope he didn't. Let's see. Technician A says a defective spark plug wire can cause an engine miss. Technician B says a defective spark plug can cause an engine miss. That's a no-brainer. They're both of them are right. What does it sound like? And you've heard me say this before. Whenever you've got a spark plug that's gapped too close or partially fouled, what do you expect to hear back in the pipe in the back? You're going to hear it going boo, 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 boo. You know, it won't be missing every time the cylinder fires, but it'll be missing sometimes. Boo, 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 boo. Irregular miss, random irregular miss. And so now occasionally you'll see one doing that way, because if it's a high output engine like what they put in something that came from the factory, you'll have a little bit of a random, you know, idle miss because of coil. I mean, excuse me, not coil, because of being cammed up a little bit. Let me see. Which of these components sends a pulse signal to an electronic ignition module? That would be C, pickup coil, right? Typical secondary coil resistance specifications usually range from 6 to 30,000. Like I say, I'm typically going to find them around 12,000 when I measure them with that. Technician A says the primary coil has more windings. Technician B says secondary coil has more windings.
C.
What did I just say?
B.
Yep, that's going to be B only. And technician A says an engine will likely miss under load if the engine coil is tracked. What does tracked mean? Anybody know? You don't know? Whenever I first started working on vehicles, most everything had points, right? All right, now this little spark plug right here, see that spark plug has got a little sort of a black, it's not a crack, it's a track. it's been jumping down the outside of that spark plug enough to where it's actually left a carbon track there. If you just replace the plug without putting a new wire in it, it's going to go back and do the same thing because it tries to follow that carbon. It likes to do that. Now what we would have is we had on distributor caps, the old black ones, they would, you know, whenever there's a little too much resistance in the spark plug, that spark started looking for somewhere else to go, it'd start jumping, hitting another post, and it would make a carbon track in that distributor cap. And one day I was working with this guy back in 1983 at the Volkswagen place, and he was pulling wires off the distributor trying to find out which one was missing because it was running so bad. And he says, when I pull one of the spark plugs wires off, it runs better. He hadn't seen it before. But, I mean, I was surprised because he'd been in the business longer than I have. But I learned that at the filling station. I says, look for a carbon track in your distributor cap. So he pulled it off and he had a carbon track. Well, I asked this other guy, who was a pretty good mechanic, he built a lot of Chevrolet engines and everything. I said, what does it mean when you pull one of the spark plug wires off and the engine runs better? And he got this crazy gleam in his eye. And he goes, I don't know, pull them all off. Maybe it'll run real good. But the fact, but the simple fact was, you know, it means you got a carbon track. Now they went away from this black phenolic stuff they were making caps out of, and they used brown and blue and other stuff that was different material, and it wasn't as bad to carbon track and all that. But when I found this out, this happened to me in 1991. These silly things here, this kind of carbon track going down the outside of the plug only happens, you know, I've only seen it on the ones that have coil packs on them. That's the only one I've seen it on, those carbon tracks like that. Incidentally, I got somebody I need to call about that because we were talking about that. Okay, now let me see. That's what a track's all about. Technician B says one wire of a waste spark coil must be grounded. That's A only. You know, some people used to say since it's making a loop, if you unplug one, two will misfire, but that's hogwash. It won't. Technician A said it seems like it will, but it won't. Technician A says use a normal spark plug when checking for spark. Technician B says the spark tester should be used to check for spark. Who's right about that? That's B. A normal spark plug doesn't provide enough of a gap to tell. And finally on number 21, a diagnostic trouble code, P0301 misfire on cylinder number 1 on a waste spark system could be caused by all of these except what?
B.
Defective pickup coil. Now, I'm going to give you, I want to tell you a little service-based story, and then we're going to be through with this test. But listen to this because it's really important. Back in 1992, whenever Ford was still building the Tempo, they decided they were going to put a cam sensor in there, and they were going to make it sequentially electronic fuel injected. Before that, they didn't have a cam sensor in there. All they needed was what they called a signature PIP. Now that little Hall effect window in the distributor, when it spun around, one of the windows was a little wider than the rest of them. That's how it knew which cylinder was on number 1. It used that little profile ignition pickup for a cam sensor, right? Now listen to what I'm telling you now. Okay, so one day, somebody rear-ended another person and broke the distributor on their Tempo. The body shop fixed it. They got a distributor from the parts room, dropped it in there, and when they went to drive it, it was cutting up, skipping. So they gave it to me because I was doing drivability work, and when I would crack the throttle a little bit, it would just pick up a dead miss on one cylinder. Just cracking the throttle just a little bit. So I put the scope on it, and I noticed when I cracked the throttle, the cylinder number 3 firing line would go away, which was just doggone weird, because that typically doesn't happen. Just a little bit of throttle angle is all it took, and the number 3 firing line would go away. Now, what had happened was, on the ones that had the cam sensor, which was reading the cam, you know, little cam sensor in the side of the block, they put a distributor profile ignition pickup vane cup in there that all of the windows were the same size. When they bought the distributor, it was a Fred Jones remanufactured distributor, it was one for an older car, and it had that oddball wider window for that had been used previously before they put a cam sensor on it. And so that confused the PCM whenever you were giving it a little bit of gas. I mean, it wasn't calibrated to have a wider window, and it would lose that signal for that number 3 firing line. And all I had to do was get the original distributor, it was broken, take the little vane cup off of it, put it in there, and all my skip was gone away. Now, if you weren't thinking clearly, you'd probably do all kinds of stuff trying to fix that, right? But it paid to have a scope. You got me? To be able to scope the ignition system, that kept me from doing a whole bunch of extra work. And I first started using a scope back in when I was at the Volkswagen place. We had a scope that moved around on a track, and we'd hook that sun scope up. And one day, when I was drawing this pattern earlier, I had one that whenever you'd give it the gas, it'd sputter and pop and cut up. And I said, well, I need to scope this. Okay, so ordinarily you got this fire like I showed about. Well, the one that I saw, when I would rev it up, every single one of these would go crazy. So that this spark line was jaggling up taller than the firing line had big ragged spikes. It was going taller than the spark line. So what do you think was wrong with that one? The fuel filter was stopped up. Had nothing to do with the ignition system. It was lean, and you remember I told you the molecules of the fuel, when they burn up, it starts to go up. This one didn't even have enough fuel for it to fire normally. And it was doing all this crazy stuff right here. And that's when I first recognized the fact that you can take an ignition oscilloscope if you know what you're looking at, and you can find all kinds of problems that are unrelated to the ignition system. You're basically looking at the effect of another cause. Mac Vandenbrink is a guy that's an expert on scopes, and he can show you how you can tell if you got a rounded off camshaft lobe by looking at the scope, the ignition scope pattern. And so it goes pretty deep if you're interested. So anyway.